Hey folks, welcome back to another video. Today we're looking at question 54201 matrix. The way we'll be approaching this problem is by using dynamic programming. Anytime you see a question that says like minimum or maximum values, and in this case it's like the nearest distance, so which is like a minimum value to like the closest zero, there's a high probability that you can use dynamic programming to solve that problem, and we'll be doing the same here. So for a given matrix, right, you don't need to find the minimum distance for each cell. What you need to do is you need to find the minimum distance that your neighboring cells have and just add one to that. So what does that mean? That means you can use dynamic programming. So the solutions that have been built previously to get to your current solution. So here in this case, right, the resulting array, the only value that needs to change is 2 right here. So if you think about it, you don't have to like step into this cell right here and look for the closest 0. All you need to do is look at the neighboring cells and check which is the closest distance, like which has the minimum distance in the neighboring cells, and just add 1 to that. So that's what we'll be doing. So let's jump into that. Let's set the problem up. So you have the number of rows, which is mat.length, not number of columns, that would be mat of 0.length, and you need to have a resulting matrix. So that will be new int of the same matrix that's given to like the same size. And you also need to have a maximum value. So the reason why we need to have a maximum value is that sometimes you don't really know what the neighboring values are, but we know that there's at least 1 0 in the matrix. But what's the maximum distance that you can possibly have, right? It could be like let's say at the opposite corner of your diagonally opposite corner of your of the matrix. So it would be like R into C. So let's just keep that as like a maximum value, and we'll see how to use that. So once we have that, what we need to do is set up the for loops, right? So we are starting from the left hand corner, so the first row in the first column. So it will be set up like this: int I equals 0, I less than R, increment I, and then you'll do the same for j. So int j equals 0, j less than c, increment j, right? As soon as you have that, like you look at the given value. So you look at if res of I of j, if it is equal to 0, we don't really have to do anything with it. So you just initialize, sorry, hold on, mat. If the original matrix, if this current cell that you're looking at is 0, we don't really need to do anything. So we just initialize res of I of j to be equal to 0, right? If this is not the case, because we've already looked at the top, at the rows above and the columns to the left, we can look for a minimum distance on the top cell and the left cell. So we try to get the minimum. So let's see, int top would be equal to, if I is equal to greater than 0, that means like this is not the first row, you can go one step above. And then you would look at res of I minus 1 of j. If not, we just put the maximum value, which is max that we calculated right here. And you do the same for the left. Let me add that. And then the left would be, you just need to decrement the column actually. So you would do this. The row would say the same, and then you check that for j. So once you have the top, what the top cell looks like and the left cell looks like, you can add the minimum value. So res of I of j would be equal to mat.min of top and left, but you add 1 to that. And the reason why you need to add 1 to that is because that is a distance that it takes, like this right here is a distance that it takes to reach to either the top cell or the left cell, right? And then you need to add 1 more because it takes 1 more step to get to the current cell. So this nested for loops, they cover the minimum, they cover the neighbors from the left side and the top side, but you haven't covered the neighbors from the bottom side on the right side. So you need another set of nested for loops to do that. So let's do that right now. So in So this starts with r minus 1, and I would be greater than or equal to 0, and then you keep decrementing I, and j would start with c minus 1. J would be greater than or equal to 0, j minus minus, and yeah, this part stays the same, and then you just need to get the bottom. So bottom, and this will be right. So if I is less than r minus 1, then you would increment I, so you're going to the bottom and getting the neighboring value. If j is less than c minus 1, and then you would just look at the right cell, so you just increment j. Awesome. So when you're looking at minimum, it has possibly been populated by a minimum value that you've seen on the left and the top cell right here. So you need to compute not just the minimum of these two things that you've calculated. So let's say bottom and right, and add one to that. But this itself is going to be wrapped in another minimum, because you need to look at the current cell and see, hey, you know what, has it already reached the minimum? If it has reached the minimum, you don't really need to update it. If not, you need to look at the bottom cell and the right cell and add one to that. Once this is done, you've actually looked at all of the neighboring cells for all of the cells. And your res matrix should have the best values for each and every cell. And after that, you just return res. Awesome. So let's compile this and see if it's okay. The first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution is of n, because you do have to go through all of the cells. And space complexity is also of n, since we are creating a new matrix to store all the resulting values. Awesome. So that's how you solve the problem. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really, really appreciate that. It definitely motivates me to make more videos.